So I want to show you this project here first, 201, and then we'll do 202. This is the simplest buffer overflow. So you have to install some software so you can compile things, and then create this vulnerable program by just copying this code, buff.c, and compiling it with 32-bit code, minus M32, and minus G saves debugging symbols, so you can do source code debugging. So I've got that all set up here. I've got the, I got to go to the right directory, which is ed201. Okay. All right, so there's buff32. I'll clear, and cat buff.c. All right, let's talk about what this program does. All right, so it loads some libraries, and then it has a main routine. The main routine has a character array that can hold up to 200 characters, and it asks you for your name, and you can scan any number of characters into there. So if you were to give it more than 200 characters your name, there'd be an overflow here, but I don't care about that overflow right now. We're going to exploit a simpler overflow. Then it calls this function called BO with name and the string date. And the purpose of this function is it should say goodbye name and then execute that command that it sees in the next one with the system C. So here come the parameters, name and command. Then it's going to copy each of the name and the command into buffers that only have 40 characters. So you can put a name up to 200 characters long, but it'll be copied into something that only has 40 characters, and this is the overflow we're going to exploit. And so then it prints out pointers to show you where the name and command are stored, so you can understand how the memory corruption works. And then it takes the command and copies it into C, and the name and it copies into name using these dangerous string copy commands that will copy without regard to length. So I might copy more into these variables than will fit. And then it says goodbye to name, so you can see what your name is, and it executes this command that it finds in C down here. So that's all it does. And so when you run this thing, buff, it asks buff, I think 32. There we are. My name. If my name is Sam, it just says goodbye Sam, executing command date, and prints the date. And it shows you the name is stored here at address ending in 20, and the command is at an address ending in 48. And that is 40 characters long because this is hexadecimal, so the distance between 20 and 48 is 28, which is 2 16s plus 8, which is 32 plus 8. So the name is here, and the command is 40 characters past it. So that means if I put in a name that's 40 characters, 10 A's, and then I put a Unix command like ls, it will execute the ls because these 40 fill the name, and the ls changed the command that should have been date into ls, and now it executed it. So now I have command injection. I just copy this here, and I can now execute any command I want by just putting in here. I can do ls, date, who am I, and so on, and it will execute those commands, ls, date, who am I. So that's the simplest kind of buffer overflow, where you just overflow from one variable into the next variable. And so you've got, you get to set this up and run it, and then you can exploit a server. I've got a vulnerable server running it, and you can find some flags on the server by executing commands in this format. So that's all there is to ED201, and it shows the simplest kind of buffer overflow, which is, by the way, very difficult to stop, where what you do is you have data that leaks from one variable into the next variable. This is not the most powerful or most common buffer overflow, but it's very hard to avoid, very hard to prevent. So let me stop this recording.